Dear students, let us discuss Horspool algorithm today. This algorithm is used for pattern matching. That is, in a given string, it will check whether a given pattern is found or not. Let us compare the traditional brute force pattern matching with the Horspool pattern matching algorithm. Very simple comparison. So, brute force pattern matching, this is a given string. I have not written the characters. Assume this is the given string and this is the given pattern string. So, this is the pattern string. In the pattern, there are only 4 characters. So, now pattern is compared with the first 4 characters of the given string. If the pattern is not found, it is shifted to the right by 1. Yes. Suppose the pattern is not found here, it is again shifted to the right by 1. Suppose it is not found here, again shifted to the right by 1. Again it is not found, shifted to the right by 1. Again shifted to the right by 1. Again shifted to the right by 1, not found. Again shifted to the right by 1, not found. Again it is shifted to the right by 1. See, in brute force pattern matching, always the shifting to the right happens by 1 position only. It is always shifted to the right by 1. So this makes the whole pattern matching very slow. So from the first character till you find the pattern string, lot of operations you have to do. Therefore, brute force pattern matching becomes very slow. Now let us see how Horspool algorithm will do. Horspool algorithm, this is a given string, this is a pattern string. Yes. Now suppose the pattern string is not found in the given string, it is shifted to the right by more than 1. In brute force pattern matching, always it was 1, whereas it is shifted to the right by more than 1. Yes. Again, it is shifted to the right by more than 1 number of positions. Yes. See, in Horspool algorithm, the shifting happens by more than 1 number of positions, whereas in brute force pattern matching, always shifting happens by 1. So this makes the Horspool algorithm faster. But how to decide pattern matching should be shifted to the right by more than 1? More than 1 means is it 2, 3? How to decide? For that, we have to construct a shift table. Very important. In Horspool algorithm, a shift table has to be constructed which will contain the number of shifts to the right. How to construct the shift table? I think directly we shall go to the operation. I will just take some examples and let us understand how to construct the shift table. Consider the pattern string Bangalore. See, in Bangalore how many characters are there? 9. Therefore the length of the string is 9. And also we consider the set of characters as capital A to capital Z and a blank character also. Therefore capital A to capital Z 26 characters plus blank 1 27, totally 27 characters. So these are the 27 characters. The first step is, since the length of the string is 9, for all these 27 characters you initialize 9. Yes. For all the 27 characters you initialize them as 9. Very good, no problem. Now just see the pattern string, focus on the pattern string. See the first character B. In front of B how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8. Therefore B is updated to 8. Next, second character A. In front of A how many characters are there? 1, 2, 3, 4, 5, 6, 7. So A is updated to 7. Next, third character N. In front of N how many characters are there? 1, 2, 3, 4, 5, 6. So N is updated to 6. Next, G. In front of G how many characters are there? 1, 2, 3, 4, 5. Therefore G is updated to 5. Again you get A here. In front of A how many characters are there? 1, 2, 3, 4. Therefore A has to be updated again to 4. Yes, A is updated to 4 again. See, previously A was 7. Now A is updated to 4 again. Next we shall consider L. In front of L how many characters are there? 1, 2, 3. Therefore L is updated to 3. O. In front of O, 1, 2. 2 characters are there. Therefore O is updated to 2. R. Only 1 character is there. Therefore R is updated to 1. Last character we should not do anything. That is E. E is the last character. For that we should not do anything. Except the last character. For all the characters we know how to compute the shift table. So now we are ready with the shift table for the pattern string Bangalore. I think it is quite simple. Anyway, I'll take another example. Consider the pattern string Kannada. So how many characters are there? 7. Therefore the length of the string is 7. Same 27 characters in the pattern in the shift table. Now all the 27 characters should be initialized to 7. Yes, correct. Yes. Very simple first step. All of them are initialized to 7. Now see the pattern string. First character is K. How many characters are there in front of K? 1, 2, 3, 4, 5, 6. Therefore K has to be updated to 6. Second character A. How many characters are there? 1, 2, 3, 4, 5. So A has to be updated to 5. Third character N. How many characters are there in front of N? 1, 2, 3, 4. So N has to be updated to 4. Again fourth character N. In front of that fourth character N, how many characters are there? 1, 2, 3. Therefore again N has to be updated to 3. Now A. In front of A, how many characters are there? 2 characters are there. Therefore A has to be updated to 2. Next D. In front of D, how many characters are there? 1. Therefore D has to be updated to 1. Last here we should not do anything. So except the last character, for all the other characters we know how to do it. I think this operation is very simple. Now we are ready with our shift table for the pattern string Kannada. Now straight away we will go to the algorithm for shift table, for constructing the shift table. We know the operation of shift table. Directly we shall go to the algorithm. We have P array which will store the pattern. The length of the pattern is m, small m, and the pattern is stored from 0 to m minus 1. Yes. And st, this is our shift table. See, in our example, a size was 27, therefore it was 0 to 26. But a size could be anything. A size is equal to 256 if we consider all the ASCII characters. If we consider only capital A to capital Z, it is 26. If we consider capital A to capital Z, small a to small z, and digit 0 to 9, it is 62. So we considered a size is equal to 27 because we considered capital A to capital Z and a blank character. Therefore it was 27. So a size could be anything. So what is the input for this shift table algorithm? Pattern string. What is the output? Shift table. Yes. Next, for I is equal to 0 to a size minus 1. What should be the initial value for all the characters? The length of the string. What is the length of the pattern? M. Therefore st of I is equal to m. All of us we have already seen initializing for all the characters the length of the pattern m. Fine. This loop will initialize m, the length of the pattern, for all the characters in the shift table. We know shift table will have a size character. Yes, fine, no problem. Now j is equal to 0 to m minus 2. See, it starts from 0, it ends at m minus 2 because last character of the string we are not considering. So if we were considering the last character also, then it would have been 0 to m minus 1. Since we are not considering the last character, because we are not considering the shift value for the last character, it is 0 to m minus 2. Yes. So ASCII value of p of j minus ASCII value of a, and st of index will contain m minus 1 minus j, because as the characters move to the right, the value decreases. Therefore m minus 1 minus j increases, the characters are moving to the front, the value should decrease. Therefore it is minus j there. I think with an example it will be more clear. This loop will find the shift table for all the m minus 1 characters in the pattern. We know the last character in the pattern will not have a shift value. Yes, beautiful. Now let us consider the pattern string as Rajkumar. Yes, Kannada superstar Rajkumar. P array. Rajkumar is stored from 0 to 7. 8 characters are there, 0 to 7. A size 27, capital A to capital Z, and blank. So this is our shift table. 0 to 26, and m is equal to 8 because the length of the 8. Now, first loop already we have executed 0 to a size minus 1. St of I is equal to m. Meaning for all the characters we have to initialize to 8. Yes, the loop executes from 0 to 26. So all the for all the characters it is 8. Yes, fine, no problem. Next we will compute this. See, m is 8 here. 8 minus 2 is 6. Therefore j has to be varied from 0 to 6. Let us slowly understand what happens. When j is equal to 0, index is equal to ASCII value of p of 0. In our case, what is p of 0? R minus ASCII value of a. ASCII value of r minus ASCII value of a, that is 82 minus 65, that is 17. So that is shift table of 17 is equal to 8 minus 1 minus j value is 0, therefore it is 0. 8 minus 1 minus 0 is 7. Therefore ST of 17 is 7. Just observe in the ST shift table. For R it is 7. Yes, very good. Next, when j is equal to 1, ASCII value of p of 1. What is p of 1? A minus ASCII value of a. That is 65 minus 65, which is 0. That is ST of 0 is equal to 8 minus 1 minus j value is 1. Therefore it is 6. 8 minus 1 minus 1 is 6. Therefore ST of 0 for a it becomes 6. Yes, very good. Next, for j is equal to 2, index is equal to ASCII value of p of 2. In our example, p of 2 is j. Therefore ASCII value of j minus ASCII value of a, that is 74 minus 65 is equal to 9. That is ST of 9 is equal to 8 minus 1 minus j value, that is 2, that is 5. 8 minus 1 minus 2 is equal to 5. Therefore ST of 9, you can just observe j value is changing to 5. From 8 it changed to 5. Next, j is equal to 3. Index is equal to ASCII value of p of 3. In our example, what is p of 3? K. ASCII value of k minus ASCII value of a, that is 75 minus 65 is equal to 10. There is the ST of 10 is equal to 8 minus 1 minus j value. J value is 3 here. Therefore 8 minus 1 minus 3 is 4. Therefore ST of 10 is k. It changes to 4. Just observe, for k it is changing from 8 to 4. Very good. Next, j is equal to 4. ASCII value of p of 4. What is p of 4? U. Therefore ASCII value of u minus ASCII value of a, that is 85 minus 65 is equal to 20. Therefore ST of 20 is equal to 8 minus 1 minus j value, that is 4. 8 minus 1 minus 4 is equal to 3. What is ST of 20? U. See, now u is changing from 8 to 3. U changed from 8 to 3. Very good. Next, j is equal to 5. ASCII value of p of 5. What is p of 5? M. That is ASCII value of m minus ASCII value of a, which is 77 minus 65, which is 12. Therefore ST of 12 is equal to 8 minus 1 minus j value. J value is 5 here. Therefore 8 minus 1 minus 5 is 2. Meaning ST of 12 for m, it is changing from 8 to 2. Yes, for m it changed from 8 to 2. Next, last, because j value should be varied from 0 to 6. Now last, j is equal to 6. Index is equal to ASCII value of p of 6. What is p of 6? A. That is ASCII value of a minus ASCII value of a. That is 65 minus 65 is equal to 0. Therefore ST of 0 is equal to 8 minus 1 minus j value, that is 6. 8 minus 1 minus 6 is 1. That is, for a, it is again getting updated to 1. Very good. In the previous slide, whatever operation we did, same type of operation, we are just demonstrating how the algorithm works. So it is just the same. I think all of you have understood this shift table algorithm. Nothing difficult, quite easy. Now let us see the operation of Horspool algorithm. Consider the following string. Kannada film industry icon is Dr. Rajkumar. I am a big fan of Dr. Rajkumar, superstar of Kannada film industry. People with lots of love and respect call him as Annauru in Karnataka. Let us search this pattern Rajkumar in this string using Horspool algorithm. We already know the shift table for Rajkumar. In the previous slides, we have already constructed the shift table for Rajkumar, and the shift table is as follows. Yes, already we have constructed the shift table. You know how to construct the shift table for a given string also. So this is the shift table for Rajkumar. Now let us see how to find the substring Rajkumar in the given string using Horspool algorithm. See, the basic idea of Horspool is to shift the pattern depending upon whether the last character in the pattern matches a particular character in the given string. Here we don't do the matching from the first character to the last character. Instead, we do the matching from the last character to the first character. We do matching in the Urdu style. So let us see how actually it is done with an example. So we shall take this string. Kannada film industry icon is Dr. Rajkumar. Let us find Rajkumar in this string. Yes, I will place Rajkumar here. Now what is the last character in the pattern string? R. This R is matched with the blank character in the string. So there is no matching. So what is the shiftable value for blank? 8. That means Rajkumar should be shifted to the right by 8. Yes, 1, 2, 3, 4, 5, 6, 7, 8. Yes, Rajkumar is shifted to the right by 8. Very good. Now again, the last character of the pattern string Rajkumar, R, that is matched with D. No, there is no matching. Therefore, find the shiftable value for D. What is the shiftable value for D? 8. Therefore, Rajkumar again should be shifted to the right by 8. Yes, wow. 1, 2, 3, 4, 5, 6, 7, 8. Yes, Rajkumar is shifted to the right by 8. Very good. Now, again, last character of the pattern string R is matched with C in the main string. R and C, there is no matching. So, what is the shiftable value for C? 8. Meaning Rajkumar should be shifted to the right by 8. Yes. 1, 2, 3, 4, 5, 6, 7, 8. Yes, Rajkumar is shifted to the right by 8. Now, again, the last character of the pattern string R is matched with the character in the given string R. Yes, there is a matching. First time there is a matching. So when R and R matches, go back to the previous character. So A and D. No, here unfortunately A and D are not matching. So whenever there is no matching, you have to shift to the right by R number of times. The shiftable value for R. So what is the shiftable for R? You should not take the value of D. Shiftable value of D you should not take. Instead you should take the shiftable value of R. The last character's shiftable value. That is 7. Meaning Rajkumar should be shifted to the right by 7. 1, 2, 3, 4, 5, 6, 7. Yes, Rajkumar. Yes, it is shifted to the right by 7. Now, again, the last character of the pattern string Rajkumar R is matched with M. No, there is no matching. Now, what is the shiftable value for M? 2. Meaning Rajkumar should be shifted to the right by 2. Yes. 1, 2. Yes, Rajkumar is shifted to the right by 2. Now, the last character is matched with R and R matches, A and A matches, M and M, U and U, K and K, J and J, A and A, R and R. So Rajkumar is found here. The pattern string Rajkumar is found in the given string. That means the pattern Rajkumar is found after 5 shifts to the right in the given string. We shifted Rajkumar only 5 times to the right and Rajkumar was found in the given string. Now, directly we should go to the Horspool algorithm. So what is the input? Given string yes and the pattern string. So pattern string should be there, given string should be there. It returns the position of the pattern string if the pattern string is found. Otherwise it returns a value -1. Yes, this is the Horspool algorithm. Yeah. N will contain the length of the given string. Yes. M will contain the length of the pattern string. Very good. ST will contain the shift table. Yes, ST will contain the shift table. We have already done this algorithm shift table. I is equal to M-1. Because I is not 0, it is M-1 because we are starting the comparison from the last character. Because we start the comparison from the end in the reverse direction, therefore I is equal to M-1. Very good. Now K is equal to 0, meaning K will be pointing to the first character of the pattern string. Initially. Meaning K directly will not point to the first character of the pattern string. K is equal to 0 makes actually pointing to the last character of the pattern string. Anyway, I think we will understand that. So now K is less than M-1 and if see K is less than M-1 means still there are characters in the pattern string. There is matching. Increment the value of K. Yes, you increment the value of K. Fine, no problem at all. See here, carefully understand. M-1 minus K, I minus K. K is equal to 0 means K will not contain the position of the first character. Instead, because it is being subtracted here, it supports the comparison of the last characters. So comparison happens in the reverse direction. Yes, fine, no problem. So when you come out of the while loop, if k is equal to m, meaning all the characters have matched, therefore k is equal to m. So when k is equal to m, it means the pattern is found. Very good. Return the position of the pattern I minus m plus 1, return the position of the pattern. Otherwise, if k is not equal to m, meaning somewhere there was mismatch of the characters, therefore I has to be incremented, I has to be shifted to the right by how much? Very important. This is where our shift table comes into the picture. Shift to the right by st of si times. Yes, we have to shift to the right by st of si times. Very good. Suppose if I becomes greater than n minus 1, then the pattern is not found in the string, therefore return minus 1. That's all the algorithm. I think you have understood the concept of Horspool algorithm. Also, you have understood the operation of Horspool as well as the shift table, how to construct the shift table, and the Horspool algorithm also. I think this algorithm is quite simple. It is faster than the brute force pattern matching. You have seen in the example, in the animations, demonstrations. Horspool is definitely faster than the brute force pattern matching algorithm. I think you should be able to write down code for this Horspool algorithm in any programming language that you want.